Good morning, everyone. It's great to have you with us for our webinar today. We'll get started in just a few moments. I'm just letting a few more people join the event. So if you have any questions during the webinar, just while we're waiting, I'll tell you that you can post them in the Q&A and we will get to them at the end of the session. So just a couple of moments and we'll get started. Thank you. Hello, if you're just joining us, we're just waiting a couple of moments just to let a couple more people join, and then we'll get started on our webinar this morning. Thanks for joining us. Hi, everybody. Thanks for being with us this morning. We're just going to wait just one more moment, a few more people. We have a lot of attendees so far, but I know we have quite a few registered, so I just want to make sure nobody misses the start. We are recording today's webinar, and you will be able to watch the recording just by clicking on this link after we've finished, and we will be sharing the slides as well. And don't forget that you can ask questions in the Q&A, and we'll get to those at the end of the session. So just a couple more moments and we'll get started. Thanks. Okay, so I think we are ready to go now. Yep, that looks like a good number to me. So I'm really happy to hand you over now to our CEO, Victor.
Good morning, everyone. So I'd love to introduce the speakers today. We'll have Jarek Stanislawek. He's the engineering manager at Bryson Recycling. Based in Belfast, he's the conductor behind all the systems working smoothly together at Bryson's Maddox MRF, which manages 50% of Northern Ireland's household recyclables. And his depth of technical knowledge has made him an invaluable first customer for Recycleye, and I'm sure a very interesting source of knowledge we can all learn from today. We also have Paloma Aldeguer. She's technical sales engineer at Recycleye. Prior to joining Recycleye, Paloma was an academic at Imperial College London, developing algorithms to optimize the layout of material recovery facilities. And today she spearheads Recycleye's efforts within Europe and with a key focus on the Spanish market. And myself, my role as CEO is working very closely with our customers to ensure Recycleye builds and delivers solutions that solve their most pressing challenges. Today's presentation will be split into three main sections. The first one, Paloma will present an in-depth overview on how AI and robotics can be used in the industry. In the second instance, we'll do a deep dive with Jarek on his experience automating his manual quality control using robotics. And last but not least, we'll leave plenty of time for you to ask any questions. But before we start, a quick overview on Recycleye for those that might not be familiar with us. Today, we're a team of 30 people. We're spun out of Imperial College London, where we still have very close ties and academics working with us every single year. We have a mutual exclusive agreement with the world's second largest robotic manufacturer, a company called Fanuc. Some of our backing comes from the likes of Microsoft, and we've also received some funding from both the European Union and the UK government. And on our board, we have people like Bernard Arambillet, the former chief executive officer of Veolia. And as a company today, we've mainly focused on municipal household waste, and today have clients across Northern Ireland, England, France, Italy, Germany, and even as of last week, our first system is going to be deployed in Australia. I'll now hand over to Paloma, which will talk about optimizing facilities using 21st century technology. Paloma, over to you.
Thank you, Victor. Hi, everybody. Nice to have you here in our webinar today. So now moving on to automation and waste sorting. So what does automated quality control look like? The simplest way I find to explain this is to see it as two separate branches. The first one being the vision system, which is powered by ML and deep learning algorithms. It bases its main tasks on image recognition. Basically, what it does is replicate the human eye, basing identification not only on material type, but object shape, shininess, size, etc. As an example, it will differentiate an aluminium can from an aluminium aerosol. The vision system then powers the robotic unit, which carries out the actual physical separation, currently operating on lines such as residual, paper, HDP, and aluminium, which we will talk about further during the webinar. Equipping robots with features like a 6-axis mechanism, path planning optimization algorithms, and empty pick detectors are some of the key incorporations that have been made possible through working closely with facilities and understanding how this technology can best support the sorting process to ensure optimal levels of operation. This diagram shows where automation is driving value throughout MRFs, from fulfilling dynamic pricing based on stream composition to developing front-end solutions. Projects of this nature are increasing granularity in classifications. So if we translate into numbers, these aspects of automation translate into key benefits for facilities. Manual pickers, for instance, naturally get tired over an 8-hour shift. With our vision systems monitoring this data, we were able to see that over an 8-hour shift, purity slowly decreases over time, and this is natural. As you can see in the little graph, robots completely resolve this challenge as they result in a consistent and highly reliable performance. In other words, there are no toilet breaks or holidays. Robotic solutions improve margins through two other angles. First one, through the alleviation of labor overheads, which has resulted in over 10 million savings over a MRF's quality control lifetime. The allowing for 24/7 operations also results in something in the likes of 110% more throughput, which means waste treatment more than doubles. If we think big and scale this to all of Europe, we could absolutely double recycling rates, which is crazy. AI automation brings effectiveness beyond other technologies. Let's take food grade versus non-food grade plastic differentiation as an example. If we think of food grade PP and PE today, there are no markets for these existing. AI has the ability to change that and transform a batch of PE, say costing 500 per ton, to PE food grade at 2,000 per ton, which is nuts. We're currently working with Total and Valorplast in France for a similar application on this. In our latest results, we actually managed to remove 50% of the food grade PP with 97% purity on the stream. So here you're seeing a clear example of where AI comes into play. Equipping MRFs to align purities with ever-changing legislation is also something crucial for robotic technology. As a case in point, the sampling scheme in the UK originally required 0.05% of the waste to be sampled. If we talk about this in absolute numbers, that's 60 kilograms out of 120 tons of waste. Just in case you didn't know, the new EPR scheme has just been published and is now 60 kilograms out of 75 tons. So the sampling frequency has absolutely augmented significantly. Introducing technology like our vision systems will allow 100% traceability on the stream, surpassing the necessary requirements by far. We actually had a very interesting discussion with RAP the other day, where we asked them to share their insights with regards to automated sampling. Some of the key benefits we discussed with them included the capacity to ramp up the sampling frequency without the need to find out found more space to store the bales and mount power capacity. More importantly, the ability to get high accuracy on proportions and quantities, which provided much more visibility in a way that producers could pay a fair amount. All of this needs to be supported with high detection accuracies. If not, it wouldn't make any sense. So AI systems have the capacity to classify a single object over 120 times, which reduces error rates significantly. We see AI as complementary to technologies such as NIR. For example, it is able to detect black items as well as basis detection on much more than material type, like I mentioned previously. As an example, the ability to sort PET trays from PET bottles, which conventional machinery is unable to do, or the capacity to sort aluminium cans from aluminium aerosols, which is actually an application we're seeing has a lot of interest in MRFs after optical sorters. I have just skimmed through several insights and benefits associated with automation, so feel free to post any questions you have on this through the chat. And now I'm handing the floor back to you, Victor.
Thank you, Pamela. So Bryson Recycling is the UK's largest social enterprise recycler based in Mallosk, Belfast. It was established more than 30 years ago and today runs 12 sites with 65,000 tons of household recycling being processed last year. The company employs 300 people and sorts half of Northern Irish household recyclables. More recently, Bryson took the decision to install a Recycleye robotic unit on their paper line to pick out material in 4 separate buckets, including Tetra Pak, brown board, aluminium cans, and plastic. Jarek, welcome. It's lovely to have you with us. How are you today?
Hello, everyone. Thank you very much, Victor. I'm fine. Great to be here today with you.
Thanks a lot for taking the time to be with us. So I have a few questions. I suggest we'll dive straight into them. Jarek, could you perhaps start by explaining why you chose to install a robot in your facility?
First of all, as every company, I believe we are looking regularly onto the market, onto the equipment on the market, into also an innovation that is possible. And due to the design of the factory, the size of machinery and so on, it's very difficult for us to find a perfect machine that would nicely fit into the existing factory, into existing machinery. So for us, it was very important whenever we're making any changes, whenever we're making any improvements. First of all, installation. We needed to prove that we can do the installation over the weekend, not to disturb working hours, what was a very, very important part. Secondly, we've been looking also for the right equipment, something that will really play a big, important role within the machinery. And as well as any other factors that really took a part in consideration of why to choose the robotic arm basically rather than everything else. And everything, I think, nicely came into the fact that we've got a new company, UK company on the market supplying exactly what we're looking for at the minute.
Okay, thanks. And could you perhaps share what the key investment considerations were?
The main 2 points really were the product quality. We are trying to ensure that our segregated materials are to the highest possible quality that is needed for the buyers of materials. And secondly, we knew that the machine will be able to long-term replace also a person on the line, because we're working over 2 shifts a day plus some operations at night time. That ensure that the robot will nicely pay off also within the time, as it will work 24 hours a day for 5 days a week.
Okay. Could you share some of the installation costs and some of the timelines you sort of saw when installing the robots?
Regarding installation, everything went really smoothly. We had very good communication between Bryson and Recycleye. The installation team responded to any questions asked. We needed only to prepare basically the new chutes towards the installation to position the robot perfectly, as well as strengthen the floor supports for the main frame of the robot. Didn't cost it much. Everything was prepared outside of working hours. Installation, because of that, was going very, very smoothly. There was no delays, no issues with the weekend installation outside of working hours. So been very pleased with that.
Okay. And how would you compare the performance of the robot versus a manual picker?
Again, on the performance, I need to make a clear statement that it's all depending on the line. First of all, what objects we've got, what objects we want to pick up, how many objects there will be treated as contamination as the target objects for the robotic arm, because that is a very key performance measure. Basically, whenever we've got enough material on the line, we're able to work between, let's say, even 30 up to 55 picks per minute. I've seen the machine working slower. I've seen the machine working much faster. So a lot depends on the details of how the machine is set up and how it can work. Comparing to manual sorter, yes, as mentioned before, people will slow down during daytime. People will take a short break, maybe to check the phone, change the music on the phone, or play a different radio station. So there is always those possible disturbances during human operation. With the robotic arm, there's nothing like that. It is working. And comparing to, I think, an average of 35 picks per minute for an employee, it makes a big difference. It is working definitely faster.
Okay. You mentioned there employees. Could you share how the staff at the facility reacted to having a robot being installed?
Well, that's very interesting, because as many people we've got in the factory, as many opinions, some people were more keen to see additional equipment installed before the human sorting processes, basically another automation process installed on the line. What was very good, and some people knew straight away how positive that's going to be, the result, that the majority of picking could be done by the robot, and they will need to do only maybe after the robot the final quality control, rather than picking more contamination. So some of them have been really enjoying the changes within the factory. Some others completely opposite. The first thinking was straight away, oh, hold on, those robots will come in and will maybe push us towards the new jobs and so on. So I think it's all communication. It's all in communication. Whenever people are told of what's happening, what is the progress of exact plans for the company as well, I think they're going through it much easier, and those changes, they are needed, but again, they have to be really well communicated to staff of what is happening.
And did you have to fire anyone upon the installation of the robot?
Nobody has been dismissed because we have implemented a robot on the line. We have reduced a position on the line with the natural movement of people. People in this field are coming and going regularly, so we just didn't replace the person that went gone basically from the position.
Okay. What advice would you share with another facility manager that might be looking at implementing robotics sorting on their quality control?
For me, this robotic arm is working really well because it doesn't have a massive framework around the position. It can be retrofitted into any position that at the minute you've got employee working or where you would like to implement a new employee. So that's very good. And in general, I would not be afraid. It is a good technology that is proving and is getting much faster on the market. As we can see with Recycleye, the machines are moving. The companies need them and wants them. So I would say definitely yes. I'm more than happy to recommend the equipment as it is proving that it's working.
Okay, fantastic. One of the concerns we've seen a lot is people commenting about the gripping ability of robots versus air jets. Could you comment on what you have found, sort of comment on your experience with the gripping part of the robots more specifically?
I like myself the design of the robot, of this robot, because at the very beginning we've installed a small nozzle, and yes, with the hundreds, thousands of movements and picking objects, it didn't last it. So Recycleye responded pretty quickly, changed a lot within the design of the pneumatic system and installed a completely different nozzle, different gripper that is lasting much, much more. It's lasting very good time. We're not worrying to see the machine with damaged nozzle or anything like that, because we know that the gripper is there, it's working, and it's working really fine. What I also love about this design and this type of the robotic arm is that it doesn't lose time on moving the object over the chute. That's one of the big differences from the spider type of the arms, where they have to move the full way outside of the conveyor to drop the material into the chute. Recycleye arm is working differently. It picks the object, turns towards the chute, and blows it into the chute, which speeds up the operation as well, clears the nozzles, makes sure that everything is working there as fine and fast. So I like it.
Fantastic. And my final question, how many robots would you want to see on your site?
I don't know, can I answer loud? I don't know who's listening, but in the brackets quietly, I will say as many as possible.
Okay, perfect. Lovely. Well, Jarek, thank you very much. And Jarek will still be there as part of the Q&A. So if you have any questions, please feel free to start posting them in the Q&A section. And I will now hand over back to Paloma.
Thank you, Victor. Thank you, Jarek. And hi, everyone again. And yeah, just to complete our explanation of this technology, we thought it was a good idea to touch on a different application of the robot. In this case, we're no longer talking about a paper line like we were with Jarek from Bryson, but plastic. We wanted to highlight this technology because it showcases the flexibility that this technology has. So this application, I don't know if you may be seeing my hands because it's a bit complicated to explain just with a picture, but it basically consisted of a line that was split in half. Many of you may know these sort of lines as it's quite common in MRFs. And basically we had half of the line was HDP nuts and the other half was HDP jazz. So what the robot was doing was actually cross-matching the corresponding categories. So HDP nuts from the HDP jazz stream, moving it to its corresponding half and vice versa, as well as removing residuals from both sides. So out of these two target streams, the outcomes were absolutely smashing. We surpassed the expectations by far. Actually, we achieved 99% purity in HDP nuts. And yeah, so this is just very briefly touching on this, showing that that these outcomes absolutely justify the need for artificial intelligence in waste, of course, complementary to other technologies, such as optical sorters, as we aim to push the boundaries in terms of purity, efficiency, and granularity. So yeah, this is a second and different application to what Jarek has explained. And yeah, I'll now hand back to you, Victor, so you can sum up the outcomes of the webinar.
Fantastic. So we spoke about robotics in different circumstances. Overall, it's clear that AI and automation has a few high-level advantages. The first is obviously you reduce your labor turnover and no longer have sort of labor shortage problems. It leads to a reduction in overhead. Automating quality control can save up to £3.6 million per year per facility. On top of that, the automation of the quality assessment, which is the sampling, can also save up to 400,000 a year for some of the larger facilities. It gives you the opportunity to move towards 24/7 operations, which if you operate on 2 8-hour shifts, means that you can almost double your total throughput. Ultimately, it's about better performance and more consistency and reliability in your waste streams, as well as characterizing that waste and bringing some more visibility and traceability to your own operations. I just want to finish off with essentially a bit of a story of how we actually got to work with Jarek. It was a year ago. Recycleye set up what was called an early innovator program, which offered early access to this new technology and preferential access to the team. Bryson was given a slot on the program in big part because of Jarek's hands-on approach, from which we were sure to get tons of feedback, on top of which we could build. Now that the whole system has achieved a much higher, is out of R&D and fully productionized, essentially how can you automate and have a risk-free transition to benefit from all the systems we've just talked about? Well, for that, we set up what's called the Zero Risk program. So this one is structured slightly differently, but it essentially allows you to transition to automation without any risk. That means that Recycleye comes to your site, installs a robot free of charge, along with so you don't pay for install, neither for the purchase. You can still place your manual picker in the exact spot where the robot is being installed. The gating allows to do that. And you only start paying a lease payment once the robot essentially achieves the equivalent of your manual pickers, and at a price that's equal to your manual pickers, so it can fit within your existing OPEX. You don't need to get sort of CAPEX approval. And then after 2 years, you can either choose to buy the unit at a heavily discounted price, or simply continue leasing it again at a lower price. So feel free to contact us. We have quite a lot of the slots have already been filled, but we have one more. So if it's of interest, let us know and please be in touch. And I believe we will now open for the Q&A.
That's right, Victor. Everyone is being fairly, perhaps a little shy at the moment in asking questions. So we'll give everyone a couple of minutes just to post any. All you have to do is post them into the Q&A. If you've got any questions that you'd like to ask Victor or Paloma or Jarek here today.
Okay, we have one coming in. I believe that one can be one for Jarek. Can humans work safely next to the robotic system?
Definitely yes. The short answer is definitely yes. The robot has the movement area closed off with a cage. There is no issue why people can't walk by or work close to the robot. It is made to UK health and safety specifications, so everything is really safe.
Okay, perfect. We have another one. I was wondering what preparations need to be done to immerse to install a robot. Perhaps, Jarek, again, could you share your experience on what you have to do before we came in and bolted on the unit?
A robot definitely needs a good solid floor, as there is a movement required by the robot, so the frame has to be solid for it. For this type of the robot, not as massive as for different types of the robots, as long as I understand. And on top of the position of it and the floor requirements, we're looking mainly for electricity, air pressure supply, and internet connection. At the minute, we can't imagine any machine that will not have internet connection. So that's definitely key to the success.
Perfect. Let's see if any other questions come through in the different panels we have here. Yeah, could you share, Jarek, some of your experiences of who fixes the unit if it were to go wrong?
The risk not as much to go wrong with the machine, fingers crossed. There is a simple maintenance processes on site that could be done by engineering team. As in Bryson, we would fix majority of small issues, and that's mainly we're talking about ensuring that the hoses are in correct positions, that the gripper is clean of anything. So maybe a wee bit of a greasing of spring compensator. So small repairs could be done that way. Because machine is connected to the internet, Recycleye has a full view of the machine, of what it does, and so on. And any issues with I don't know, settings of the software or changing to the software, changing items that we want to pick up. For example, our robot is picking different types of materials during day shifts, then switching off certain target materials over the night shift, as this operation doesn't need all items to be removed from the line. So all things like that can be changed remotely by Recycleye, and that works really smoothly.
Okay. We have another question that's come in. How does the robot deal with small particulates and liquids? And have you had problems with blockages in the system?
How it deals with blockages? At this moment, we haven't got really blockages on the system. Whenever we had the very first weeks, the smaller nozzle and maybe that's the size of it was causing some certain small blockages in it. Since the upgrade of the pneumatic system, the size of the gripper itself, we didn't really see any blockages there. Nothing really happened there. So there wasn't anything like that. Liquid, I can't really answer because we haven't got really any big issues with liquid anywhere. Some plastic bottles would have a wee bit liquid in them on our line. And I didn't notice any issues that the robot would not lift it. I'm not talking about full bottles weighing around 2 kilos. I'm talking about maybe small plastic bottles with some content in them. So I can't really comment too much on that one. And anything really tiny, anything small, obviously small items are left on the line because the system is not recognizing it as a target to be lifted. So there's no big issues with that. It's all depending on a few factors. One, the software, settings of the software. Second, material we're putting for the robot to work on. So again, it's that design of where do we want the robot to go on. We've installed our one on the fiber line, paper line, where we wanted to concentrate mainly on picking Tetra packaging and also cardboard, brown board, and it's working really well. On top of that, works and removes also any plastic, different types of plastics from the line if there, and aluminum cans as well. And it does what it says on the box.
Perfect. We have two questions that came in. I think I'll take those. The first one is whether the system can be applicable to construction and demolition waste. So the answer there is yes, the vision system is entirely applicable to CND waste. There's not a big difference in moving from, say, a paper line to a PET line to to a CMD line. It's just scanning new material types. However, the robotic system is currently limited to items sort of below the 1 kilogram weight. So it can be fine if you're talking about, very back-end small items, small pieces of wood in CMD. But today our system cannot do the larger construction demolition waste items. And then another question is, can dust in the air be a problem for the recognition system? To date, I don't, and I'll let sort of Jarek also comment on that. But we haven't necessarily worked in facilities that have, the normal waste facility obviously has some dust. The advantage of AI, it's a lot less sensitive to near-infrared. So near-infrared sensors need to be cleaned on sort of almost a daily basis to make sure they perform very well. We have one client in France. We know for a fact that they only clean the camera bit once every like 5 months with a little piece of cloth, and it's been working fine. I don't know if Jarek, you have any comments on the dust in the air problem, or if you've seen anything with the unit you have installed.
First of all, we've installed a machine in the cabin where our manual pickers are working, what means that we can't have dust in this area. It will be very, very limited. Any movement of dust or air in the building where people are present. So I can't say how it might work in the dusty conditions. However, I know myself, I didn't clean the camera glass yet.
Perfect. And in terms of security for the future. So a question with regards to security for the future, whether the AI processor is local or controlled by remote. So the answer there is all the AI processing takes place on site. The main reason for that are twofold. One, it's a lot faster than sending it into the cloud. And two, we don't use Jarek's entire bandwidth to send up live high quality footage into the cloud as well. Obviously, if the system gets disconnected from the internet, it also means that it can just keep on working autonomously. If it is not collected, what we do in the cloud is sort of things like our active learning pipeline, where over time we just always enhance the systems and throw updates down back to the system. But it just means it won't necessarily get future upgrades. It also blocks the data flow. We have dashboards that are accessible to Bryson. The data would no longer flow in those cloud dashboards. They would, however, flow still directly into the local SCADA system, where the data can also be taken directly into facility control platforms. And then we have, so there's a question on the weight and size limits for Spider Gripper. So for Spider, I'm assuming you mean a Delta. So Recycleye took the active choice to not go ahead with a Delta unit, which is sort of those long ones with the long legs, and instead go with a 6-axis model. There were several reasons for that. One is indeed weight carrying capacity. A 6-axis is a lot more robust. That also translates into ability to just less maintenance. If stuff do sort of knock into it, it's unlikely to, it's just a much more robust system. More systems have been deployed. The 6-axis ability gives us the ability, as Jarek mentioned earlier, to not necessarily having to pick, move, and sort of drop an item, but we can simply pick, rotate, and shoot an item. We just got $500,000 from the European Union to also do software updates so that we're no longer just picking items directly down, but also at sort of angles to always make sure we take essentially, target an item wherever we have sort of the most planar surface that we can possibly have on the unit. And then, okay, we have another question. What are the benefits of combining existing NIR technology with visualization system of Recycleye? Paloma, perhaps, do you want to answer that one?
Yep, sure. So as I mentioned earlier, we do believe that it's complementary. So we see it as two pieces of different technology. So it wouldn't be comparing apples with apples, but some of the main differences include, for example, black object detection. So as you know, NIR doesn't have the capacity to detect black objects. Our vision systems have no problem as they use very granular light calibration, so they could see. We have some videos of that in our webpage, so feel free to search for them, or we can share the link of that, where you're seeing black trays on a black conveyor belt, and it's detecting it perfectly. Another difference is also the ability that it has to detect items away or further than just material type. So the example I gave earlier would be, for example, aluminium cans from aluminium aerosols. There's actually one client we've been talking to specifically, which had an optical sorter working with NIR on an aluminium stream. And the case in point there was installing a robot afterwards to be able to separate the cans from the aerosols, because there's a different value added to both of them. So that application with artificial intelligence is not a problem at all, whereas NIR doesn't have the capacity to do that. So those are, for example, two cases where AI can complement NIR or can do something different that NIR is unable to do.
Just to complement on Paulina's answer, she's talking here, I see sort of 3 sections. That's the stuff only AI can do. There's a big section where both actually AI and near-infrared can do the same thing, you know, say paper sorting versus your plastics, even within your paper sorting, your brand board, etc. The advantage of AI is just a more robust system in terms of maintenance. It's using LED lights instead of halogen, and a simple camera instead of a near-infrared, more sensitive sensor. There is a small section where AI cannot do what near-infrared is doing. So that would be, for example, limited specifically to, say, white PE pots and white PP pots. The system will definitely struggle in detecting those. However, in that scenario, we're actually in the PPP space. We're doing, for the first time, food and non-food grade sorting, which near-infrared itself can't do. So the future, in our view, is very much going to be a blend of the 2 technologies. We have another question on your recognition differentiates between paper and asbestos objects. I'll be honest, I can't answer that question because we've never tried to detect asbestos. So yeah, we'd need to learn more about asbestos and visually what they actually look like, and in a mix, what they, how they would be visualized. The key rule of thumb to understand whether our system can detect items is if a human can detect the items, then we can teach the AI system to detect them, because it's very much based on the same mechanism.
Yeah, to complement what Victor said, another thing that usually people ask us quite a bit is, in those cases, for example, where you're talking about a new application like paper versus asbestos would be, is how fast can you make the machine learn? So initially, when we first deployed one of the first vision systems in France, it took us about a month to generate the necessary data for the machine to run smoothly on that line and on that waste stream. We recently deployed a unit in Italy, which was a brand new market for us, and it took us less than a week to have all that data up and ready for the machine to run smoothly. So the way we've set up the architecture of the algorithm to actually learn efficiently and quickly how to learn to recognize those different and brand new objects is very, very fast and very powerful.
So we just have one last question, Victor, that's just come in. Do we have any plans to enter the CDW field? I'm
assuming CDW is same as CND. Please comment in the comments if it's not. So today, our main focus is household waste. With regards to the robotic sorting, we're not yet working on sort of larger units of the robots, which we can quite easily do, because the whole architecture, collaborated with FANUC. Actually, if we do want to go in CND, we just replace our robot with a slightly bigger model, but all the software protocols and exchanges between the units will remain the same. We have also started to work with several optical sorter manufacturers that are embedding our AI within their sort of optical sorting technology. And in some of those use cases, it goes beyond just the typical sort of household waste. And so there are other applications that they might use their systems for, including also sort of car sort of parts, etc. But yeah, beyond household waste.
Great. Well, I think that might be the end of our Q&A, unless anybody just wants to squeeze in one last question for our presenters. If you do have any questions afterwards, you can just send them through to us in using hello@recycleye.com, or just or send us an inquiry through the website. If not, I think that is the end of the Q&A. So just it remains to thank our presenters today, particularly our special guest, Jarek Stanislawek from Bryson Recycling. Thank you very much for being with us, Jarek. To Paloma and to Victor for, I think, an interesting and very helpful presentation today. We hope you've enjoyed being with us, and we look forward to seeing you on our next webinar. Have a lovely day.
Thank you very much.
Thank you very much.
Thank you.